All right. Thanks everyone for coming. So we're going to start with my favorite slide, which is I will follow the design recipe. So as I mentioned in the previous exam review, one of the most common things people don't do in the exam is they don't follow the design recipe, which will lead you to sort of do worse off than, if you followed the design recipe. So even in this exam, I will say stick to the design recipe, especially for the trees and mutual recursion part, because those kind of get complicated. And if you're following the template specifically to design your functions, you'll be in a much better off position overall. So for today's agenda, we're gonna talk about list abstractions, and in list abstractions specifically, we're gonna write these in the list template form, just so that you can sort of visualize how these are written and how these are working. And for Foldr, I know like a lot of students still don't completely understand how Foldr works. So we are going to have like a table form of a visualization thing that showcases how the entire function works. And it's only going to be there for Foldr just to kind of explain that one concept. And then you can follow the same table concept to like, trace how a filter would be working or how a map would be working. The next thing we'll do is we'll be looking at locals and lambdas, and we'll be using these locals and lambdas in combination with list abstractions to see kind of how like these are fitting inside list abstractions and how the inputs kind of go from one place to another. The last thing I will touch up upon is multiple complex inputs, how to deal with inputs that are sort of like same types and how to inputs that are of two different types. And then I'll pass it off to Jonathan and Sean, who will be focusing on trees and mutual recursion. Yeah, so let's get started. So the first thing we're going to tackle is fold R and fold L, because this is something that we have discussed like multiple number of times, and people still don't like, understand how it completely works. So the first thing we want to know about Foldr is what are the things it is taking in. So it takes in three specific things. It takes in a function that takes two types of data, data X and data Y, and it converts it into a data Y. The second thing it takes is sort of like a base case or kind of like a variable that will keep updating over time to give you a final result. And that data will most likely be of the type Y, because that is what the final case would kind of return. And then the third thing, since this is a list abstraction, we will have a list of input data type, which is a list of X, to kind of take individual elements, run it through the function, convert it into of type Y, and then return the type Y database, the database. So it returns a single data type matching the base case, which is usually of the type Y. The main difference between Foldr and Foldl is even though they essentially do some, like similar things in terms of like inputs and outputs, Foldr works from the rightmost element to the leftmost side. So in a list, the rightmost element is going to be empty, right? And then from empty, it moves to the lastmost element and the second last element all the way up till the first element. Fold L is sort of the opposite way around, where the first thing it'll do is it'll take the first element of the function, apply it with the empty, combine it together, and then sort of like from there, it starts moving on until the rightmost element, and then it gives us the final output. And so we'll discuss how Foldr and Foldl can sort of make your implementation different as well once we start designing the functions on Dr. Racket. So let's get started with designing the Foldr function. So I'm going to call our function my Foldr, just to kind of ensure that it does not mix up with like the actual Foldr function. And let me just increase the size of this. Okay. So we know that the Foldr will be taking in a function that takes in two inputs and it returns one output that is of type Y. It takes a base case or a data that keeps updating of type Y, and it takes a list of X and returns the data type y, right? And so it essentially applies function to each and every element, and then it combines it into a single data type. The one thing just to remember, it sort of sounds similar to map, but map essentially runs the function onto each elements and returns a list. Foldr returns a single data type. That's one of the major differences between Foldr and map. So the purpose statement would be something like applies the function to each element and combine into a single data type. Let's write some check expect. So for check expect, oops, sorry. For check expect, what we're going to do is we're going to compare our Foldr function to actual Foldr function. And so what I mean by that is if I write something like, let's say my Foldr, let's say the function is specifically the plus thing, the base case is going to be 0. And let's say I give it list 1, 2, 3, 4. Most of you will tell me that, okay, Harsh, based on this, our output should be 10. But that is not what I'm going to compare it to. I'm going to compare it to the fact that does it return the same output as Foldr, right? So if I compare it directly to Foldr, it should give me the same output. And through all of the list of abstractions that we're going to discuss, I'm going to write check expects in a similar way, where essentially my built Foldrs can my built list abstractions can compare to actual list abstractions inside Dr. So let me just copy another check expect, because we should always have two check expects. So in this case, we're comparing if the addition works the same way. And in this case, we're comparing if the division works in the same way. All right. So the next thing we want to do is obviously start off by writing the function. So I will have something like define my Foldr that takes in a function. It takes in, let's say, I usually call y as the base case because that's how I remember it easily. But if you have like some other way to like remember it, you can definitely use that variable as well. And then it takes in a list of x, right? So with a list, we know that we deal with two specific conditions. The first is empty, right? And if it is empty, we want to return a data type that is of type y, right? So if I put an empty list here, can someone tell me why that would be incorrect? Feel free to like unmute.
Because you want to return a type Y, not a list.
Sorry, can you repeat that?
You want to return a type Y and not a list.
Yeah, perfect. So an empty list is essentially going to be a list, right? And we don't want to return a list. We want to return the type Y. So what we're going to do is we're going to start with the base most case, right? Which means, let's say if I ran this specific function, right? And this list was empty, I would essentially be getting 0 as my output, which is what my base number is. The second thing I would be looking at is if this element, if there is an element in the list, then we know we want to do something on the first of the list, and then we want to do the recursive call onto the rest of the list, right? So the function will remain the same. The base will remain the same, and we just have the rest of LOX over here, right? So this is roughly what our function would look like. So one of the things now we need to figure out is, okay, what are we going to do over here, right? And based on the output, we know we want to combine it into a single element, right? Which means sort of adding all of these numbers together. And so essentially what we'll have is we'll have that function itself run over here, because then what it will do is it will add, let's say 1 onto the recursive call. It'll then get 2, it'll get 3, it'll get 4. and it'll sort of add up all of those numbers together. Does that make sense, or did I confuse anyone with this? Okay, I'll take the silence as everything is clear. So if I run this specific piece of code, both my tests pass, which means I sort of created a function successfully that kind of replicates what Foldr does, but in the list template format. Okay, so before I go to fold L, I know a lot of you had struggles in specifically understanding or visualizing how Foldr works. So I sort of made this table format to kind of visualize how we would be adding numbers. So let's say if my main function was dealing with adding up numbers with the base case 0 and a list of 1 to 3, right? As per my code, I would be doing plus over here. I would be extracting the first number and I would be getting the recursive calls output over here, right? Which means my first number is 1 and my recursive call would be my Foldr plus 0, the rest of list 1, 2, 3, which is list 2, 3. Then the function will sort of go around to calculate what my Foldr 0 to 3 will do. It will do plus 2 recursive call onto a list of 3. It'll run a third time where it'll do my Foldr 0 and 3. So it'll understand, okay, I want to do plus 3 onto the recursive call, which is 0. And then the last thing where it reaches the base case, it'll give me 0, right? And so if I look at the results, right, I'm essentially going from like, 1, 2, and 3, and then there's like an empty list over here. And it's at the empty list at the point where I'm starting to evaluate what my results are, right? So it's at this 0 mark or at the empty mark that I first evaluate that my answer is 0. So we know that Foldr for empty will return 0, which means in this specific case, I should be doing 3 plus 0, which is what I have here, which is equal to 3. Then the second thing is I should be doing plus 2 of this recursive call answer, which is 3. So 2 plus 3, which is 5. And the last one is plus 1 of the recursive call. So this recursive call is equivalent to this recursive call, which evaluates to 5. So I do plus 1 onto 5, which is equal to 6. And so that's how the Foldr function is working. It's evaluating from the rightmost side all the way up till the leftmost side, and then it's returning a final value. Any questions on this? Okay, if you have, feel free to like put it in the chat later on and I can answer it. So the next thing we want to look at is the fold L function, right? Fold L does the same thing, but it moves from the left side onto the right side, right? So what I'm going to do here is I'm essentially just going to copy this entire function down and then start changing it based on how Foldl would work. So Foldl would have the similar signature, which is x, y to y, y, list of x, and then y. It will apply the function to each element and combine into a single data type. I should be changing my function names and then comparing it to fold L's. And here is where we're starting, right? So we know that the basemost case is going to be the empty check, right? And if it's the basemost case, we just want to return the base data type. But what sort of changes in this entire function is how we implement the fold L function if we are sort of like, doing it in the list template format. Because in this case, we're just kind of recursing and applying the function. In fold L, what we would have to do is we would actually have to apply the function on the first of the number. And if we are adding, right, we need to add it to something, right? So we'll be getting the first of the number and we'll be adding it onto the base, right? So just for you to kind of think about it, right? We know that at each iteration, right? Our recursive call will stay with the same function, right? Our LOX will keep changing, but in fold R, our base is only changing once the rightmost element is reached. In fold L, our base changes each time we make a recursive call. So this may look a little confusing, and if it does, do let me know and I can walk over it. But essentially what we're going to have is a direct recursive call over here where the function stays the same, right? We'll do something so that our base data type keeps updating on each iteration. And we know we want to recurse on the rest of the list, right? This is how the structure of fold L will look. So in this case, we are reaching the rightmost element and then starting to evaluate. In this case, we are starting off with the firstmost element, right? So let me break the problem down to a little smaller problem. Let's say, given a function, given the first number, and given the base, right? I want to apply the function onto the first two elements, right? How would I do that? So let's say if I had something like a plus, right? The first element is 1 and the base element is 0, right? So if I wanted to add these up, I would do plus 1, 0, right? Which means I'm using the function onto the first of my list onto the base, right? And then the next time it runs, it's essentially going to do something like my fold L with the plus sign. It's going to have 1 evaluated over here, and then it's going to recurse on the rest of the list, which is list of 2, 3, and 4, and so on and so forth. So as per this thing, we are essentially evaluating first and then recurring. On fold R, we are recurring, reaching the end case, evaluating, and then coming back all the way. So I would have a simple function call, right, which is like the plus sign onto the first of the list of X and the base element that we have over here. And so once I run this specific thing, all 4 of my tests pass. So before I move on, did everyone understand how fold R and fold L worked and how each element is being processed? Feel free to like stop me if you have any questions. Okay, so I'll again take the silence as everyone understood it and you don't have any questions, which is great. The next thing I wanted to cover is, when do we use fold R and when do we use fold L? Because if, let's say, in the exam, we gave you a question regarding, hey, you have to use a list abstraction for this sum question. And then you realize, okay, I can use fold R or fold L, but now I'm not sure which one to choose. There's essentially an easy way to kind of understand like how to choose between both of them. So we know that fold R works from the rightmost side to the leftmost side, and fold L works from the leftmost side to the rightmost side. So the first thing you want to evaluate is, does the order matter, right? So in the case of addition, right, the order does not matter because I can do 1, 2, 3, 4, or I can do 4, 3, 2, 1, right? I'm going to get the same output, which is 10. But if I'm dealing with division, 4 divided by 1, and then 3 divided by 4, and then 2 divided by 3, and 1 divided by 2 is different then 1 divided by 1 divided by 2 divided by 3 divided by 4. So, okay, let me just let me run the function to kind of show you a different output. So fold L will give us 2.666666. Fold R, on the other hand, would give us 0.375, right? So in the case of division, the order makes a big difference about the output, right? And so if you figure out that based on the problem I have on hand, if the order matters, then you sort of need to consider, do I need to start from the base case or from the first element, right? So like once you read the question, you just need to like understand that, am I updating it and then recurring, or am I recurring until I reach the base most case and then starting to evaluate the answer? And I don't have like a good example ready with me to like sort of explain like the wording of the question, but you like based on the question, you should be able to read and able to like figure out, do you need to go from the left to the right or the right to the left? And once you sort of figure that out, you know which fold to use, fold R or fold L. But always just remember, like just be sure to ensure that the order matters or it does not matter. Will we be asked to recreate abstractions like this on the exam? No. So you don't need to recreate the abstractions. The reason I'm recreating the abstractions is because A, it breaks down how like each of these abstractions work. And then B, if you still have like, if you're still unable to visualize how list abstractions work, you can do like this table format kind of a thing where you have like the function call. You can look back at the code and do like, okay, what expression would this thing have? And then what are the results going to be? And then kind of like make a table to like visualize how to specifically get an output from a list abstraction. Why is the base case for folder, and why is one the base case for, oh yeah, so as Duncan mentioned, we can't put 0 because if I start dividing 1 by 0, I'm gonna get infinite, and then Dr. Racket can't evaluate it as well. And as Sean mentioned, yes, like if I did multiplication with base as 0, I would always get 0. So I guess one other thing to just remember is, if you're dealing with multiplications and divisions, you want to start off with 1. If you're starting with additions and subtractions, you want to start with 0. So that is how you can sort of remember it if some question like this comes in the exam. Any other questions before I move to the next thing? Okay.
I had a quick question on this, just like the image you're showing here. Because it almost looks like when you move to like the +2, 3 equals 5, it looks like the base case is updating to 3, but you said fold L is where the base case is updating.
So,
but is no, go ahead. Yeah.
So what I was saying is, in this specific case, the base case does not update until we reach the empty case, right? So essentially what we're doing is running the function onto the first and recursing. In fold L, what we're doing is running the function, updating the base case, and then recursing. So that's slightly different, because like let's say in this case, right, I'm doing +1 of the recursive call, and the recursive call is not evaluated until I reach the empty most case. And once I reach the empty most case, that's the point where it starts evaluating and then getting the answers to like kind of update the base case and give me a final value. So that's why it's kind of going from the right to the left, because if you think of this list as list 1, 2, 3, and then the last element would be empty, it goes to empty, evaluates from there, then 3, then 2, then 1. With fold L, we are sort of just saying that, okay, we are going to start with sort of the empty first. So let's take the 1 and the empty, update the base case, then update the 2 onto the base case, then update the 3 onto the base case. And that's why it goes from the left to the right. Does that make sense?
Yeah, that makes sense. Okay, thank you.
And so in the case, like, let's say you're reviewing the stuff and you're unable to still figure out how fold L worked, or if you forgot what I mentioned, feel free to like create this table, because it'll help you like visualize how the entire function is working easily. Okay, so the next list abstraction which we'll deal with is filter. Filter, it's a very simple function. It takes a specific list and a predicate, and for any element that the predicates return true, it only returns that specific elements. And for any element that the predicate returns false, we don't want those elements at all, right? So let's look at how to design the filter function. So let's say my filter is a function that, as we mentioned, takes a predicate. The predicate is always of X and returns the type Boolean. And then we take a second variable that will be a list of X. And so since filters is only recreating the list of X, but with certain elements there and certain elements out of it, we are going to return the same list of X. So there will be no type change in this data. So essentially it gives back the elements which are true for a okay, we have a question. How is the yeah, okay, so Duncan has put the answer, right? So essentially what we're doing is we are doing 1 divided by 1, which will give 1. Then we are doing 2 divided by 1, which is now updated to okay, here's what I'm going to do. So let's say we're dealing with my fold L with the what's it called, the division sign. The base case is 1, and then list of 1, 2, 3, and 4, right? What we're kind of doing is we're saying divide 1 by 1 first, right, which is the first element in the basemost case. So this will result in 1. Then the second thing which we'll be doing is we'll be dividing the first number, which is 2, right, onto the updated base value, which is 1. So this will give us 2, right? Then the third thing we'll be doing is dividing the next value, which is 3, onto the updated base value, which is 2, which gives us 1.5. And then the last thing which we'll be doing is dividing 4 by, sorry, not 3, by 1.5, which I don't know directly what the calculation would be, but will be 2.66666 recurring on till like forever. And so this is how Dr. Racket represents like the like 6 going on forever. Yeah. Okay, coming back to the filter function. So we need a couple of check expects over here. So I'm gonna write a check expect with the base case and a check expect with the other case. So let's say the first case is check expect my filter. I want to deal with odd numbers, and I want to see if this produces the same output as the actual filter function. And similarly, what I want to do is I want to see if a list of 1, 2, 3, 4 produces the same filter output as list of 1, 2, 3, 4. Right. So we're going to have the same list template, which is my filter. We know it takes in a predicate, or yeah, let's go with pred, and it takes in a list of X. We check for two specific things. The first case is if it's empty. If it is empty, then this time we are returning a list of X, right? So the basemost case of a list is always going to be an empty list, right? And then the second thing we check is if it's a cons, then we want to do something on the first of LOX and then the recursive call. So my filter right, that is that is what like the rough template would look like. So now we kind of need to figure out, okay, what are we going to do over here? So does anyone want to give me like a hint what I should be doing next? Anyone want to just take a guess what we would be doing with the filter?
The predicate.
Right. Yeah, predicate, right? So we want to run the predicate on the first of the element, right? And then once we run it on the first, we want to run it on the second, third, and fourth, right? So what we'd be doing is we'll have an if expression where we run the predicate on the first of the LOX, right? And so let's say in this case, it would be odd ha onto 1, right? If odd ha onto 1 returns true, which it would, right? What we want to do is we want to keep 1 in our list, right? So to keep 1 in the list, we essentially just do cons of the first element onto the recursive call, right? Which means add 1 and then keep running it on all of these numbers, right? But let's say the second part of the if expression is what if this is false, right? So if it is false, right? Like let's say the predicate is odd ha and the number is 2, right? So if it is false, we don't want that number at all, right? And the way we would kind of tell Dr. Racket that we don't want to get that number is we would just avoid doing all of this cons part. We would just do the recursive part so that it keeps going on to the other elements and keeps checking for those elements. So we'll essentially have just my filter with the pred with the rest of the LOX. And so once I run this specific thing, all of the tests pass, which means I've successfully created a filter function that matches the actual filter function. So just to recap, the filter function will run on each and every element over time, right? And if for any element we get true for the predicate, we want to add the element onto the recursive call. The recursive call will work to create the remaining list, right? And if the predicate is not true, then essentially what we'll be doing is just doing the recursive call so that the current element is not added onto the recursive call. And that's how you would think about making a filter function. Could I use append instead of cons? No. So if I used append over here, and if I ran this specific thing, it would give me an error which says that check expect encountered an error. Append expects a list given 3, right? That's the main error. So the reason append would not work is because if you try to do append with 3 onto an empty list, append only takes in 2 lists, right? And so it wouldn't essentially work in that same way because 3 is not a list, and so we'll get this error. The other thing you could do, which I personally don't recommend doing, is you can convert the first to a list, and now you can append the list of the first number onto the recursive call. It's a very inefficient way of doing it, but if you are more comfortable with like just using append, you can you can go ahead using that. But I'm gonna keep the function on cons. So I guess one thing to just remember is cons can add a single element onto list. Append adds a single, or not, adds one or more lists together. Is there a difference between using cons and oh yeah, I just covered it. So if you are dealing with single elements, you want to use cons. If you're dealing with lists and you want to put it on top of another list, then you want to deal with append. Because if I did something like cons of list 1 2 onto a list of 3, it would generate like a list where the first element is another list and then the second element is 3. And so now I'm sort of dealing with a list of numbers, which I don't want to be doing. I want to just deal with a single list. So yeah, that's how you should remember it. Cons is for single elements. Append is for if your first is like a list of if your first is a list, or if you're like running the first onto some helper function which is kind of returning a list, then you want to use append. Any other questions on this? Wouldn't append need minimum 2 lists? Yeah, so append needs 2 lists. Actually, I think append works even if I do, yeah, append actually works without 2 lists. But if I just do one specific thing, then it would return like just the normal list itself. Like it doesn't do anything onto it. What does the adds a 1 mean? Oh, sorry. Adds 1 or more list together. My bad on that. Yeah, so it can deal with like a single list, and I think if I try, yeah, if I do append without any single list, it would just give me an empty list. So it works on 0 or 1 inputs, but I most likely we won't ask you to run it on 0 or 1 inputs. If we do ask you to run it, it'll be on 2 or more lists together. So I'm gonna change this to 2 or more lists for now. Just so that you don't get confused when you're kind of reviewing it later on. All right. So the next thing we want to look at is the map function. So map function takes in 2 specific things. A function that, sorry, map is not a function, map is a list abstraction. It takes in a function that converts a single data to another type, right? So like, let's say if I'm dealing with strings, it can convert it into numbers. And then it takes a list of, let's say, strings to convert it into numbers. And the final output would be usually of a new type, list of y, but it can be of the same type as well. So like, let's say if I gave it a list of numbers and my function was just to add 1 onto each of these elements, I could get back a list of numbers as well. But the reason we generalize it as a list of y is most likely it's to convert it into a different data type. And even if it's the same data type, you can stick with a list of y. That is not an issue. Okay, let's look at map. So the mymap function will take in a function that converts x to y, right? And then it'll take in a list of x so that our final output can be a list of y. What it would do is essentially takes a function and applies it onto each element of a list, and creates a list of a new data type. Okay, so for check expects, here's what I'm gonna do. Let's say if I'm dealing with let's say if I want to just keep the output the same, like output type the same, I will do something like add 1 onto a list of 1, 2, 3, 4. And this should essentially produce a list of 2, 3, 4, 5. So the only reason I made the check expect slightly different is just so that you can sort of visualize how the output would be. But we want to ultimately compare it to the map function that is pre-built in Dr. Racket. So I'm going to take this, I'm going to replace it over here, and I'm going to say run it on the map as well. And another way I could write it is, actually, let me just copy this. Let's say if I'm dealing with string dash length, and let's do A. So in this case, we should be getting the same output as the map of the string length of A, B, and ACB, which would essentially be a list of 1, 2, and 3, because the string length in this is 1, string length in this is 2, string length in this is 3, right? So the function, again, we sort of start with the list template where we have the mymap function that takes in a function and takes in a list of X. We check for 2 specific cases, empty, and if it is empty, we want to return an empty list, right? Because our base case is a list. So we would return an empty in this case. The second thing we would check is if it is a cons. And if it is a cons, we want to run some function onto the first of LOX and then do the recursive call, which is mymap. Same function, just the rest of the list. Right. So this is roughly what the template would kind of look like, right? Now, if we think about the map function, what it's doing is we know that for each element, it's gonna apply the function onto the first of the element, right? Which means we need an fn over here to apply the function onto the first of the element. The second thing which we would have to do is we need to combine both of these elements, right, to return a single list, because right now if I click sorry, the bracket will close over here. If I click here, right, this is one part of my one part of the answer clause of the cond, and this is another part of the answer clause. And the answer clause of the cond is always going to be just a single part, right? So if I actually ran this, Dr. Racket would give me an error that expected a clause with a question and an answer, but found a clause with 3 parts, right? And the reason it would say 3 parts is because this is one part and this entire thing should be one part as well. So since I want to build up a new list, essentially what I would be doing is I would be consing the first element that is running through this specific function, and I would cons it onto the recursive call so that it can build me that new list. And so now when I run it, all my tests pass, which means I've now successfully recreated a map function that does something similar to what the map function in Dr. Racket does. Does anyone have any questions on map? Okay, if not, let's move on to the next thing, which is Andmap and Ormap. So both of these functions, they kind of do similar stuff, right? They take in a predicate that takes in an X and converts it into a Boolean. And it runs on the list of X. And what it does is once it sort of runs it on the Boolean, the final output will return a Boolean. And the way it will return a Boolean is in the case of Andmap, if all of the predicates return true, then Andmap returns true. Or like if any one of the predicates return false, then the Andmap will return false. In Ormap, we just need one predicate to return true and the final output will be true. Otherwise, it'll return false if like all of the outputs are going to be false. So let's move into creating our Andmap function. So we start with the my Andmap function that we know takes in an X and converts it into a Boolean and takes in a list of X, and our final output would be a Boolean and returns true if predicate is true for all elements of the list, right? For the check expect, I have some check expects sort of ready, so I'm going to use those check expects just to kind of save on time. But essentially, what we're doing is if the list is empty, we want to check if it's the same for the and map for empty, for 1 2 3, for 2, and for 2 and 1. And just one thing I also want to touch upon is, let's say if I was not comparing this to the actual Andmap function and I wanted to write what the output would be the output be true or would the output be false? Anyone want to take a guess about whether the empty list would return true or whether the empty list would return false? Okay, perfect. Yeah. So the empty will, sorry, not the empty will, the empty list will return true because the empty case is the base case, right? And so if Andmap gets even a single false, it would return false, which means if the empty case is returning false, we're never going to get true in the entire Andmap case. So we need to ensure that the empty case returns true. So let's move into writing the specific function. So I'm just going to copy this and I'm going to change this to Andmap. Does that apply for every predicate? What do you mean by does that apply for every predicate? Yeah, so regardless of what predicate you put, if there is an empty list over here, it will always return true. So I can write the most complicated functions over here, but it will return true. I'm trying to think of an example if it can return false in the case of empty case, but I can't think of any specific cases because yeah, I'm gonna go with it always returns true because I can't think of any example where it would return false. But if any other TAs have any examples about it returning false on empty case, feel free to like pitch in as well. Okay, so Andmap takes in a predicate and a list of X. For the empty case, we know that it will return true, right? So we want to return true. And for the cons case, we know we want to do something. We want to run the predicate on the first of LOX, and we want to do the recursive call over here, and sorry, and we want to do the recursive call, right? So the predicate will run onto the first of LOX. It will evaluate whether this is true or false, right? So this specific piece of data is a Boolean, and then all of this recursive stuff will return us a Boolean, right? So the way we would want to compare if all of our Booleans are returning true or false is we would have something like an AND, which will do AND of the first Boolean and whatever the resulting Boolean is. And based on that, the output will be returned as Boolean. On the exam, should we be using the symbol notification like you did here, or stick with the list notification? Sorry, okay. I I think since I was writing these, like since these were pre-written, I chose the symbol notation, but either option is fine. You can go with this or you can go with this. Ideally, I think what you have been taught this semester is to mainly follow this. So I would follow this over this. But in any case, we will never penalize you for following like one of the two options. Like both can create lists, and so it's fair to assume that either one is fine. But yeah, like use whatever you're comfortable with, either list or either the symbol notification. That's fine. Yeah, so as Jonathan said, that symbol notifications sometimes do have strange stuff related to it, so I would not cover it. The only reason is that if I do something like A like that, I think it creates a list of the symbol A. So it might get confusing, but since you're not specifically writing code in Dr. Racket, we are less likely to penalize you if you somehow made a small mistake that leads to like a list of symbol A over a list of the string A. Because if you wanted a list of string A, you would have to put like the quotes around it to create like a list of A. Yeah. Okay, moving to the next part. So yeah, Andmap essentially, if it's empty, it'll return true. We'll keep doing the recursive call, keep generating like a bunch of Booleans, and then do AND on top of all of the Booleans. The next thing we want to look at is the
before you do real quick, I guess the one thing I wanted to mention though, I guess going back to the question where is there a case where the base case is false? I still can't think of any, but in general, if you might have any doubt that the base case is going to be true, that's kind of the reason that we write check expects. So as long as you're creating a result from the function that you anticipate to be correct, if you make a base case that's true and then somehow it's not working as intended, then maybe I'd take a look at it. But in general, yeah, I've never seen a base case as false for an Andmap. But yeah, just make sure that if you have any confusion, that's why you write a test for it.
Yeah, I agree with that. So with Andmap and Ormap, the way I think of it is Andmap is basically saying, is there a single one that fails? And if it fails, then it's false. And it's the same for Ormap. Ormap's like, for Ormap, if there's a single one that fails, it's false. And for Andmap, if there's a single one that's, sorry. So
Way around.
Yeah, Ormap, if there's a single one that passes, you can say it's true. Andmap, if there's a single one that fails, you can say it's false. Yeah. And if you have an empty list, you don't have any things that pass or fail. So you go with like the default. So for Andmap, it'd be true, and for Ormap, it'd be false.
Yeah. And just in case if you're getting confused with like this method, I know like some people also write Andmap in the following way, where essentially instead of this AND, they check if the predicate is true, right? So if the predicate is true, they want to do the recursive call to understand whether the final thing should be true or not. And if the predicate fails, they just return the false as the thing. Sometimes it might get flagged as a lack of Boolean simplification, because in the, like, you should be avoiding cases where you're writing something like if some condition true false, because this some condition will evaluate to true or false. And so writing this is essentially kind of indicating like a lack of Boolean simplification. So I prefer this method over this specific method. But like if you're designing and if you somehow wrote it in this case, I would assume it is fine, but it depends how strictly we are looking for like lack of Boolean simplification on the rubric. Yeah, so just so that you don't get confused, I'm going to stick with the first one. Okay, the next thing is the Ormap. So the Ormap takes in the type X, converts it into a Boolean. We have a list of X and we return a Boolean. If you're checking for everything.
I was just thinking, sorry, I just wanted to address Frank's idea there. If you wrote an and map to check everything that fails, I was kind of thinking about that too, potentially. Generally, the way that I would approach that if I had a test like that is either, you know, what was I going to say? Basically, if you're checking for everything to fail, then your function is probably going to return true if every single item fails the predicate that you're writing. Because an and statement inherently is going to basically be outweighed by any false that exists. So yeah, basically stick to the whole true base case thing. That's your safest bet.
Yeah, and I think Duncan put a specific example to kind of test the limits of the and map, but I don't know if everyone can see this correctly, but essentially what he's doing is he has an and map where he has a lambda inside, which compares if the list is Boolean or not, is false or not. And he has a list of bunch of false. So in this case, since each element is false, the false goes in the lambda. And then once you compare that the Boolean is false, the Boolean is returning true. And so essentially what's happening is you're kind of comparing both of them, returning the opposite of the list, and then ensuring that everything is true. And I would flag this for lack of Boolean simplification, because you could have written something like and map not and a list of false. I think you have false like 3-4 times. So it converts each and every element into true, and then it does an and on top of all of the trues. And so now you're getting a true. Yeah, I'm
feel
not
like
sure.
we might be delving too deeply into this where people might start getting a little confused.
Yeah, okay. So I'll stop taking like more complicated examples of
Yeah.
and map, but yeah, just stick with this and you'll be fine. Yeah.
Yes, I highly doubt the professor will give you some kind of trick question that will do this. Like, so stick to the base case being true is my advice.
Okay. And now just to save on time, I'm gonna give out the pre-written stuff, and we'll just copy the and map and see how to change this specific case. So let's say if we're dealing with my Ormap, right? The first thing we want to do is, for the empty case, we should not be returning true, right? Because if the base case is true, then we are always going to get true. So in this case, the base case is going to be false, right? The next thing we want to do is we obviously want to run the predicate onto the first of the list. This will return either true or false. And we want to do the recursive call, which is the Ormap the function and the rest. The only thing changes over here is instead of the and, we just have like an or. And essentially once we like, what did I do? Oh, I made this red. Yeah. So once we run this, everything passes. So just remember the difference between an Andmap and an Ormap is the base case, which is true and false, and essentially just flipping the and to an or. The rest of the code essentially just looks exactly the same. Yeah. Does anyone have any questions on Ormap? Okay. If not, we're going to move on to local and scope. So I have a function written over here, which essentially does nothing, but I've sort of used like a normal function, a local function, and a Lambda function just to kind of teach you about like A, how it's written, and B, when to sort of use it. So let's say we write this main function, anything that is written on top over here, right? These are global variables that are accessible by anything that is written underneath over here. So this map can access the global variable, the Lambda can access the global variable, the local can access a global variable. So global variables are anything accessible by any function inside the local scopes over here. And the way you can think about it is sort of like a public variable in a way for those who have Java knowledge. The other thing is local variables. So any variable that you're defining inside the Lambda over here or inside the local over here, these are local variables that can only be used within this specific scope. So if you have Lambda with local variable 1, this local variable 1 can only be called inside the Lambda function. Like I can't call the local variable 1 over here. The way I'm passing this local variable 1 to the local is by saying that, okay, call the local function where I'm taking the element that is given to this Lambda function and then is being passed onto this specific thing. So you don't need to know what this function is doing. The only point of this function was to tell you what global variables are, what local variables are. Locals are written over here, like right underneath the define thing. Lambdas are usually like, it can be written anywhere. So it can be written in check specs, it can be written inside the locals, it can be written inside the maps. So obviously the main question you really want to know is, when do I know when to use a helper? When do I know when to use a local or a Lambda? In general, if you're like, let's say if you're creating a helper function to break down the problem, if your helpers are relying on these global variables, sorry, if they do not rely on the global variables, it is a good practice to have a helper function, because you want to separate it into a different function so that you can sort of test the function and ensure that that smaller part of the problem is working correctly. Because the problem with local and lambdas are you can't really test those specific functions. So like, let's say if I built an entire game with like 10-15 helper function which are all local, and even one of those functions fail, I will never know what functions are failing because I don't have any tests written for that. So in general, if your helpers are not relying on the global variables, you should be using it as a helper. I don't think so. Sean and Jonathan can maybe speak to this as well, but I think in most cases, if your helper function does not, or if your local helper function does not look very complicated and does not rely on global variables and you still made it a local, I don't think we have deducted in that case, but you should be just following the rule in general. Can you
I
give
think
it?
that one of the reasons to have local scope is so you can define helpers that the rest of your program doesn't need to see. So even if they don't rely on global variables, I think you can still use it in a local scope if it's like a really specific helper function that no one else is going to care about.
Mhm.
I think between local and lambda, I would say Lambda is like really, really simple. It's like one line of code.
Yeah.
If you actually need to use like brain power to understand what the Lambda is doing, you should do a local instead.
Yeah. Yeah. So
Yeah. Another use for lambdas is to, pass certain, basically like if you're iterating through a list, you can pass like items from that list into a helper function, for example. So like you can use lambdas inside of list abstractions as a way to, move values around, basically. And yeah, kind of adding on to what Jonathan said, basically Lambda, that's supposed to be a very brief line of code. Local, that's more for actually designing an entire function. And in terms of using helpers, I'd say for one, if your function is getting really complicated and really big, and it's really hard to understand just at first glance, then I would consider breaking it into a separate helper. But other than that, yeah, the main use for a local helper or a Lambda helper is basically to isolate the code that you're writing from the rest of the program. Like only that function should be able to execute the code that you wrote. So
yeah, perfect. So just recapping what they said, because it was still written here, but yeah, so essentially if you're not using a helper, you have to use a local or a Lambda. You would use a Lambda for less complicated stuff, usually 1 to 2 lines. If you're dealing with anything like conditionals or recursion, you want to use a local, because I don't think you can do recursion onto a Lambda because Lambda functions are not named. So you can't call that same function because the function is not named. Okay, I see I have a couple of questions. So Zeneb is okay. I don't know if the pronunciation is right, but for the example, we have a couple of examples ready that I will walk through. So just hold on to that for a minute. Ashna, if using a list abstraction, when do you have to put the function used in abstraction within a Lambda versus just being able to write the function name with the list abstraction, if that makes sense? So are you saying something like, when do I have to do something like Andmap of Lambda ... versus Andmap of let's say odd. So if this, okay, yeah, perfect. So if this is what you meant, so essentially if there is a pre-existing function that can already do what you want to do, you can just put the name over here. So this can be like a helper function or a local function, right? So let's say if you have designed a local function that can take in an X and convert it into a Boolean, you can essentially just write the name over here. And each time the Andmap takes the element, it passes it on to that local helper function, and then you sort of move ahead. The time when you would use Lambda is if you don't have a predefined function, and if you're doing something very similar, very like small, right? Like let's say if you're doing something like string length of, sorry, Lambda will take in an X. So let's say the Lambda takes in X as its input, and you calculate the string length, and if you want to see if that is equal to 1, right? It's a very small function that is less than, one full, or it's one line essentially, and that's the point where you can use Lambda. But if you want, you can write this function either as a local function, or you can even write it as a helper. But since it's like a very small piece of code, Lambda is definitely useful. So like think in terms of complexity, I guess. Lambda, the least complex stuff. Local, slightly more complex stuff. If you're writing like more than 2 functions in your local scope, you should definitely start considering where to use helper functions, because local is meant for like 1, at max I would stretch it to 2, not more than that. What if the function isn't predefined? Yeah, so if the function is not predefined, then you can use Lambda right over here, as I've done that, right? Or I can write like a local function, and that local function has a name, and now I can just put the name of that local function over here. So Andmap will call that function with a single X element and just pass it on to that local function. Yeah, locals require signature purpose. Actually, Troy, I'm not 100% sure on this, because the thing is, until last semester, we have been doing like signature purpose statements and check specs. I think this semester, Professor Shivers has not been using it. So I'm not 100% sure if you're required or not required to do those on the exam. But I think if you didn't put them, that should be fine as well. I would confirm this with the professor on Wednesday, or yeah, like in your lecture, that do locals require signature or purpose statements or not. But usually we've required them. Only the check specs are optional for the locals. Henry says, I find that a common scenario is an if statement with a lambda, easy to write. Would local be better? Yeah, I would say if you're using an if expression, I would particularly put it in a local. I would not put it inside a lambda, unless you have, like, if you're okay. So if you're writing something like this, where it's like if some condition, and then your second line is big and your third line is big, I would not put it on the local. And in this case, since you're also recursing, that doesn't make sense for local, for lambda, I mean. But if you're doing something like if some condition 1 0, I guess that could work, because it's like under a line. So yeah, if it's like a very small if expression, you can go ahead with it. But if it's going to be a large one, you want to stick to a local instead.
It really is kind of like trust your intuition there. The main thing is make sure that it's easy to understand. Like, put yourself in the shoe of a TA. If we're glancing over your exam really quickly, we don't want to see a lambda function that's like 4 lines long and that gets really, convoluted and hard to understand. The main thing is just keep the code as clean as possible. And sometimes that means break into a local instead of using a lambda, because then you can, write out a signature and purpose and actually explain what you're doing and take a little more space to write that function. So general guidelines to maybe 1 to 2 lines for a local, or sorry, a lambda leaning towards 1 line. So
yeah, I'd like to add that like the reason we do these signatures and purpose statements and tests is to, like, before we write the function, to kind of figure out what the function is supposed to do. And if it's complicated enough to have like 3 or 4 lines, I think that sort of planning is going to be really, really helpful when you do write a local. And when you write a lambda function, when you write that function as a lambda and you don't have those things to help you, it'll be difficult to write.
Okay, so if there are no other questions, I'm going to move on to the next thing. So yeah, okay, now we're going to go into the fun stuff, which is now what if we mix abstractions and like helpers and local helpers and lambdas inside each other? That becomes like really complicated stuff. And we're going to have some fun stuff. Okay, so I think one of the most complicated things that I've seen people struggle with is they know they need a helper function or a local or a lambda function inside the abstraction, but they just don't understand what is it supposed to take in and what is it supposed to give out. And the easiest way you can figure out is based on the list abstractions that you're using, what is it that the specific function or the specific predicate that you're passing is doing, right? So x, like let's say in the case of map, it takes in an x, converts to y. So if you're designing a helper function that is specifically for a y, it's specifically for a map, you know that you're going to take in individual elements of x that the map is going to pass from the list, and you want to convert it into the type y, which sort of depends what your assignment or what your question is sort of asking you to do, right? So you can essentially, like, if you have the list abstractions and the signature sort of written down, you can look at each of the functions that it's taking in, and you know it that it's always going to return like going to take in the same inputs and going to return that same output. So you have like sort of a trick up your sleeve where you know what it should be doing. And just one thing to note, Foldr and Foldl helpers are the only ones which take in like 2 inputs. So you're taking in the current element that you're on and the base case that you're sort of working with, and then you're updating it so that you get like a new base case in this function. Rest all of them sort of just take in one single input and give out one output. So yeah, just remember, in most cases you're only taking in one single input. In the case of Foldr, you're taking in two inputs and you're returning one output. Okay, so any questions before I move to some concrete examples of abstraction plus helpers? Okay, if not, let's move forward. So this is the fun part, which I like. I like to make my questions kind of interactive and related with like pop culture. So let's say, okay, now we're sort of moving to the file that is available on Piazza as well, if you wanted to look at it. Where is that? Yeah. So on Piazza, you can see exam2 student copy, and this is what the student copy is. So I'm sort of editing like whatever that I have given to you until now. So we're sort of dealing with a structure which is called a criminal record, where we are storing the names of criminals, the total number of crimes they have committed, and which officer caught this specific person, right? So let's say the Pontiac Bandit was like the most notorious one in the entire show, and Jake hated him a lot. So Doug Judy was caught by, let's say, Jake Paranta. And so we have like a bunch of other examples. And we have a Brooklyn Nine-Nine record, which is essentially just a list of criminal records. So I have created like a list of all of the people that, all of the records that have been there in Brooklyn Nine-Nine. I've not literally taken all of the records because I would go insane trying to make that, but let's say like a small subsection of it. So the first problem that we're dealing with is this list is sort of great, but it's complicated for Raymond Holt to kind of understand what the information is showing. So he wants to store the information about each officer efficiently. And so now what we need to do is find a way such that given a Brooklyn Nine-Nine record and an officer name, he can get a list of records from each officer. So if we look at the signature, right, we essentially want to take in a Brooklyn Nine-Nine record. We want to take in a string which represents the officer's name, right? And we want to return a Brooklyn Nine-Nine record, right? So if we go back on this specific case, right, we're essentially taking a list of X, right? So which is sort of true for all of them. And we are still returning a list of X again, right? And based on that, we know that filter is the only criteria that fits that case, right? Where I'm taking a list of X and I'm returning a list of X. Map comes close, but it's gonna change the data type. So we don't really want map. We want a filter which will return the same list, right? So the first thing we would be doing is, since we know we want to use filter, we would do filter with some function, and we want to run it on the list of criminal records, right? Which is what we have over here. Now comes the second part. So we can't just compare, like we can't do string equals, because a list of criminal record is essentially a structure, which is a record with the criminal name, the crimes, and then caught by. And so we want to compare this individual name inside the structure to this specific officer, right? So let's say if we have to use a local function for this, right? So let's say local, and we're going to do define. I need to think of a name. I'll go with like officer, which specifically takes in a criminal record or I'm going to go with sorry, I'm going to go with CR, right? Or this is why you need signatures, because officer should be taking in a criminal record and it returns a Boolean, right? And so if we compare it to this specific case, our helper function is taking in X, which represents a criminal record in this case, and it takes in a Boolean. Sorry, it gives out a Boolean, right? So we do that. And what is it that we want to compare? We want to compare if the record dash caught by for that criminal record is the same as the given officer, right? And so since this is string and this is also string, we would essentially just be using a string equal and then compare it to the officer and then just close this specific function. And so over here, I can use officer which will essentially do this specific thing. Okay, oh boy, sorry, my bad. I did not realize that I'll have to comment out all of my stuff, but essentially 7 of the 12 failed, which means 5 passed, which means all of these 5 passed. So I guess the other thing I can do is I can start a bracket over here. I can close a bracket over here and lock this code and run this. And yeah, so all of the 5 tests are now passing, which means this thing specifically worked. And coming back to Ashna's question about using like the name, since this is already defined over here, we can essentially use the name. Another way we could have written it is, what is the shortcut to run the code? So if you're on a Mac, Command R, if you're on a Windows, Control R. Is record dash caught by from the structure? Yeah. So record is the name of this structure. Caught by is the officer name in that structure, right? And so this is taking in a list of criminal records. Filter will pass in an individual criminal record where we are extracting the name of the officer that caught, and then we're comparing it to given officer name, which is right over here. Yeah. And so another way we could have written this is, let's say I didn't want all of this stuff. I could have done Lambda CR, and I can just copy this specific thing. Just ensure that the brackets are all right. So if I block this piece of code, and if I run this, this should work as well. Yeah. So I guess like this much should be fine if you're using for a Lambda. But if this sort of exceeded further, I would prefer doing a local over here. But any, like both of them, the methods are sort of fine in this case. On the exam, you can like choose to go with this option because you can sort of avoid writing the signature and the purpose statement. Yeah. All right.
But also, you'll never get points off for writing a local instead of a Lambda. Yeah, so it's like, don't fret too much about, whether using a local is appropriate. The only thing is that a Lambda can get long, and then we, probably mark off some points for unclear code. But it never hurts to use a local. So
yeah, so that's a good point. Like you can get points off for putting a Lambda, which is too long, but you can never get points off for putting local instead of a Lambda. So locals are a safer bet to play if you want to do that. I had written a tougher exercise over here, which I will not go over because it will run out of time, but you can sort of try to figure out. It's just essentially implementing the same function, but instead of taking in the string name, we would be giving in a predicate that took in a criminal record and returned a Boolean ha. So essentially, instead of this thing, we would be passing in like a Lambda function over here to kind of run inside the function and then deal with the entire thing. So you can try it on your own, and if you have questions, let me know about it. Okay, let's move on to the, yeah, there are no questions. Okay, let's move on to question 2. Okay, so one of the best things about the show, which I particularly like, is they play this best detective / genius game. So I thought I'll recreate something of my own. So let's say Captain Holt wants to decide who the best detective / genius is. He decides that the person who makes the arrests with most crimes committed this year will win the award. He designs the following scorecard data definition: given a record, return a scorecard with the number of crimes committed by criminals categorized for 4 officers. So let me just, sorry. We missed on one specific part. In the first one, there was a part of the question which says, how do we store the information for like to reuse it easily? Essentially, you would want to create constants where you're kind of just writing that the record of Jake is get record function that takes in the entire record and takes in the name. And so now this constant is sort of stored with all of the list from this. So you don't have to like rerun this function again and again. Could you post the starter code for this at some point so we can, starter code is available on Piazza right over here. So if you click on this, you should be able to open it and walk through with me if you want, or later on if you want to try it on your own. So yeah, essentially creating constants and storing information inside them is like running the function once, and then you have information forever to kind of run multiple times. Another thing is, sorry, I realized one thing, that the starter code was slightly not updated. So this question is kind of different on the starter code. In the starter code, I was talking about just arrests, but that was a very simple function. You can try implementing it. In this case, we are looking at not just arrests, but like the total number of crimes committed, which means now we're going inside the record and we're looking at the crimes field specifically. So let me walk you through the scorecard data definition. So a scorecard is essentially just a structure which has 4 fields for each of the officers that want to sort of compete in the program for best detective / genius. And so all of these are essentially just positive integers which kind of keep track of how many number of criminals they have caught. And so we'll obviously start with the base case, which is going to be everyone on 0, and then use it to kind of update it over time, right? So given, so we want to generate a function that, given a Brooklyn Nine-Nine record, generates a scorecard of the total number of crimes made by, I'm going to skip the purpose statement for now because I changed the specific question and then my purpose statement is wrong based on that. So essentially what we want to do is we want to run through each and every criminal record, and we want to add up the totals of all the crimes committed. But when we are adding up the totals, we also want to ensure that it's adding up in the right scorecard. So this is kind of where it sort of gets complicated. So let's say we're dealing with a single list and we're returning a scorecard, right? Which means it's converting it into a single data type. We are not returning a list, right? So where is the, so going back on the what's it called, the list abstractions, we know that Andmap and Ormap are going to return Booleans. We know that the map and filters are going to return list of X and list of Y. We know that the folder is the only thing that returns a single specific output. So we know we want to deal with a folder over here. So I'm going to do something like folder with some specific function over here, and the list of records that we're passing from here is going to go into individual folder cases. The other thing that I sort of forgot is the base case over here, right? So since the base case is going to be a scorecard, we want to give it a make scorecard 0. So on each instance, this helper function is going to get a single criminal record, and it's going to get the current scorecard, and it's going to update and give a new scorecard. So this is a very tricky one, because instead of using like a base data or an atomic data type, I'm using like a structure over here, which sort of makes it complicated. But all we need to remember is the helper function will specifically take in a criminal record. It will take in a scorecard, and it will return a scorecard, right? So we just want to keep running through that function and return a scorecard. Can we pass in the score dash base constant we defined? Yes, we can do that. The reason I didn't do that is I thought it might confuse people, because all of this data was not, previously there. So it's just kind of difficult to wrap your head around it. But since the make scorecard is essentially just 0, 0, 0, 0, we can put the score dash base, which refers to this specific scorecard as well. In this case, I know our helper function is sort of going to get complicated. So I'm going to stick with like a proper helper function instead. So let's say my helper function will be called get score, right? So we know that the get score function will take in a criminal record, it will take in a score, and it will return a scorecard. It will essentially update the scorecard based on the crimes committed, right? Now let's start by defining the specific get score data type. Get score function. So it takes in a CR, it takes in let's say score, right? And the first thing we kind of need to check is which officer caught this criminal. Because the thing is, the scorecard has 4 fields. It has Amy, it has Jake, it has Holt, it has Boyle, and it can have other officers such as Scully, right? So to check, oh wait, I have this written down, my bad. Okay, get score. To essentially check how it's gonna work, what we would need to do is we would need a condition that checks for 5 specific cases. It checks if Jake was the one who caught the criminal. It checks if Amy was the one who caught the criminal, Holt, Boyle, and what if there was like an else case, right? So these are the 5 conditions that we're sort of dealing with. To check that, we essentially want to do string equals harm, where we are doing the record dash caught by of the current criminal record, which will get us the officer name. And in this case, I'm going to stick with just a string comparison. So I'm going to go with Amy Santiago. Okay, so if I put that, now it's comparing if the officer that caught this specific criminal is Amy or not. And so similarly, we want to have like 4 other cases like those. And we want to see if Jake Peralta and right. So we want to check if one of these 4 conditions is met, right? And if one of the 4 conditions is met, we want to like update the scorecard such that we can now get like a final scorecard. If none of these 4 conditions meet, we still want to return a scorecard, right? So what would I put over here such that I can just return the same scorecard? Not the CR, because CR is not going to return a scorecard. It's gonna, yeah, just score. Because score is what the scorecard represents. CR is the criminal record, so we don't want to return the criminal record, right? Okay, so we handled the last case, but we need to like figure out a way such that we can now update the score. So one of the most common ways which I know people would do is do something like a make scorecard where they individually extract like all the 4 specific things. And since Amy is, let me go back to the scorecard definition. Okay, since Amy is the first specific person in this, we would do something like a plus over here and then the rest would remain the same, right? But let's say if I wanted to abstract it such that given any person's data, I can update the single number. So I would write a specific function that is something like, let's say, update score, right? And I know that I only want to update the first element inside a scorecard, right? So I would do something like record dash crimes of the CR, which extracts the total number of crimes committed, right? And this would like, since I want to put this in Amy's specific category, which is like the first thing over here, the rest numbers I'm going to give is 0, 0, and 0. And so now what I'm doing is I'm essentially writing a helper function that takes in 4 numbers and returns a scorecard. And the reason I'm doing that is because I don't want to extract all of the information again and again. Because like in this case, I would have to extract Jake's information. I would have to extract Holt's information. I would have to extract Boyle's information in order to recreate a score, right? And so I would do something similar for all of these people. Would we get points off for not writing update score? I don't think you would get points off for not writing update score, but actually, wait, let me think about this. So we're dealing with a criminal record and we're dealing with a score. It's a base case condition where I feel like making a helper definitely makes it more like less complicated. So I would want to have a helper, but I'm not really sure if like not putting the update score will deduct or not. Sean and Jonathan, what do you think?
I would say the same.
Which is like yes to deduction or no to deduction?
I think no to deduction. I think should be okay.
Okay.
But like you said, it does just help.
Yeah. So in this case, I wanted to like deal with abstracted functions. So that's the reason I'm sort of abstracting it into a single thing. And the next question is, are you going to write it as a local or pass it as the current scorecard? So here's the thing, since in this case, I'm just passing in numbers, right? I need the access to the score, right? So I would need a local function inside over here in order to write the update score. But if I was doing something like, let's say, update score that takes in 4 numbers and it takes a scorecard, then I could write it as a helper function. But since I'm not doing that, we're going to write a local function. So let me change the zeros over here. So we want to ensure that in this case, 0 is for Amy that is being added. The crimes is added for Jake, who's on the second thing, Holt is on third, and Boyle is on fourth. So we want to reduce 2 zeros from here, and we want to add 2 zeros over here, and we want to reduce all 3 zeros from here, and we want to put 3 zeros here. This is, I mean, in terms of arrangement, I feel this is slightly similar to the cross build list thing we sort of did. Okay, so now I need to write the update score function, which I'm going to write as local. So the update score function takes in 4 positive integers and returns a scorecard, right? So we sort of know now what we need to do. So it's going to take, let's say, Amy, Jake, Holt, Boyle. And since we are recreating a scorecard, what we need to do is we just need to do make scorecard, right? And the individual templates of the scorecard would have been scorecard dash Amy of the score and similarly all the 4 fields, right? So Jake, Holt, Boyle, right? So this would essentially create the same scorecard that we're dealing with. But if we want to add the total number of crimes into the scorecard, any idea how I would do that? It is a tricky question because like I designed it to be much complicated, but yeah. Okay, so you're saying plus A onto the Amy scorecard, but what if I'm on the Holt case where I'm sort of dealing with Holt? Then how does this function sort of change such that I can accommodate for Holt as well? Because in this case, I'm just accommodating for Amy. Yeah, perfect. So since all of these other numbers are 0, right, we can essentially add all of these 4 numbers onto these individual scores, right? And so we can essentially just have plus A onto this specific thing. We can have plus J onto Jake's score, plus H onto Holt's score, and plus Boyle onto Boyle's score. And so in case you're confused, like, wouldn't it add up 4-5 scores together? The answer is no, because in the update score, I'm only passing in one person's score. The rest are all 0. So like, let's say if the Amy Santiago case was hit, it would get the total number of crimes committed by any criminal that Amy caught, and it would only add the number over here. The rest of these are like 0, right? So it will just keep the numbers same. And so since this is a more abstracted function, because over here, what you would have to do is you are in each of the cases, you would have to extract Amy, Jake, Holt, Boyle, right? So you're extracting 4 things 4 times, so 16 different lines. And then you're only updating the value for one of them. In this case, you can sort of update it for all 4 of them together and then just pass the numbers separately. Would we get points off if we put something like num to scorecard as the signature and were less specific? I would say most likely yes, because some like it sort of depends on the rubric. If the rubric states that, okay, we need the number needs to be very specific, then we would have to deduct it. If the number doesn't need to be specific, then we don't have to deduct it. The only thing is, like in this case, since the number has to be specific because it can't be negative or it can't be integer, sorry, it can't be like any normal numbers, this would have to be like positive integers, or actually these would have to be natural numbers because 0 is not positive, right? Yeah, okay, so these would these would have to be natural numbers because zeros are not considered as positive integers, so we would need naturals over here. So I, as a TA, would probably get a point or two off for doing that. Okay, so that is what our local function would look like, and the reason we used a local is because we are using this global variable inside this local function, right? And so if we do that, and I thought I blocked off the code at some point. I'll figure it out. Local expected a definition but found a part. Did I? Oh, I forgot the define. Okay, if you did forget the define in the exam, I don't think we would have noticed as much. So no point deduction there. And these should not have brackets over here. So this and remove this. Yeah, so all of the tests passed because each time one of the cases are hit, we're getting the crimes that are committed based on that officer's name. And then we are passing it on to this update function, update score function, which is an abstracted function that can sort of create a new scorecard. Any questions regarding what I did? Because I know this is like the most complicated thing because we are dealing with a folder that deals with a helper, where this helper deals with an abstracted function that is inside a local, and that is creating a different structure altogether. I don't think the exam should be more complicated than this. In fact, it should probably not be as complicated either, but I just sort of went overboard just to kind of see how you do. Wait, what is the folder doing in this question? So the first thing we're starting off with is the entire list of records, right? And so if you're dealing with a list, the folder is essentially getting a single criminal record and passing it to this helper function. And it's passing the scorecard until now. So based on whatever the scorecard is updated at, it's able to like take that updated scorecard, add some additional points onto it, and then give a final updated scorecard back to the get arrests function. That's what it's doing. Any other questions before I move on? Okay. If not, the next thing I wanted to talk about is multiple complex inputs. So I know we're reaching sort of the 8-ish mark, but I'm guessing it might go overboard to 9-ish. But since this is being recorded, feel like if you have something, like feel free to leave and you can view it later on as well. But yeah, multiple complex inputs is essentially when you're traversing through 2 or more recursive pieces of data. Most commonly, if you want to give you an easy example, it's going to be like dealing with 2 lists. If we want to really go and sort of trick you, we're going to give you 2 trees, which is like dealing with 2 mutually recursive data structures. But it can be in any format. It can be like a list plus recursive structure, list plus tree plus tree, or any other permutation combination of this. So there are usually 2 ways of handling multiple complex inputs. The first way is traversing through both of the inputs at the same time. And then the second thing is you have 2 functions instead, where you're traversing through the first and removing individual elements, and then passing it on to the second function to be able to like run it on the second helper function. So what I mean by that is, sorry, just give me a minute. Okay, so covering multiple complex inputs. The first way I said is like looking through all of the permutations and combinations of the complex inputs and then running through both of them. So let's say if I have to define a list for multiple complex inputs, so I'm doing a template. Let's say I'm dealing with two lists, a list one and a list two, right? There are four specific combinations that I can have. I can have both the cases being empty, one of them being empty and the other being a list. I can have it the other way around. So in this case, like the L1 can be empty and L2 has something. In this third case, L1 has something, L2 is empty. And in the fourth case, we can have it such that both of them have something, right? So I can essentially write an AND which checks if L1 is empty and L2 is empty. And if that is the case, since this is a template, we know we want to do something, right? The other thing is, I'm going to get rid of this. And okay. The second case is, let's say L2 has a cons, right? So we know we can't really do anything with the L1, right? But we still can do something with the L2. So the most common thing you would be doing is running some function onto the first of L2, and you would be recursing it on top of the multiple complex input template, where the L1 would stay the same because you can't do the rest onto an empty, right? But we can do the rest onto L2, L2, right? So that is kind of what that specific instance would look like. And so this example would essentially be something similar for the third case as well, where if we are specifically dealing with, let's say if L2 was empty and L1 had something, we would do something on top of the L1. We would have the recursive call onto L1, but we would not have a recursive, we would not have the rest of L2. The L2 would stay the same. And then finally, we come to this last case where essentially we'd be doing some specific thing on top of the first of the list of L1, first of the list of L2, and we want to do the recursive template onto the rest of L1 and rest of L2. And so that's kind of what the entire thing would look like, where we're checking for four specific cases. And in this case, in these two cases, we're only recursing upon one specific list. In this case, we're recursing upon both the lists. The second way to do any specific thing is having like the two function approach in a way, which is essentially something like this. Okay, wait, I'm just going to separate it out so that people don't get confused. So the other way I can do it is I can have something like a define MCI 10 V2 that deals with a list 1 and a list 2. In this case, I'm specifically going to focus only on recursing on L1 and not on L2. So if I was to do that, I am only checking for two cases. I'm checking if L1 is empty. And if L1 is empty, then I want to do something over L2. It can depend, like in some cases you can just return empty, in some cases you might want to do something with L2, so it depends. The second case is if the L1 has a cons, then I want to do something with the L2 helper that takes the first element of L1 and it takes the entire L2 list. So what we're doing here is we're sort of separating it out into another helper function that is only taking a single element of the list. So now we have a helper function dealing with one element and one list instead of two lists. And the recursive call will essentially be mci-temp v2, where we want to recurse on the first list, but we want to keep the second list the same, because if you're running an individual element on top of this entire list, you want to ensure that the overall list is intact. So that's the first part of it. The second part of it is defining that helper. So since the helper will follow the same template, we're gonna get like, so I'm gonna call this L1-data because this is not a list anymore, and this will be L2-helper. So in the case of L2-helper, if the second element, if the second list is empty, right, we can't do anything over the second list, but we can still do something over the L1 data, right? And if the second list has a specific element inside of it, then we can essentially just run some function on top of L1-data and first of L2, and then recurse it onto L2-helper. In this case, L1-data stays the same, and we recurse onto rest of the L2. So this is another way we can kind of write our functions. And so if you're wondering which ones to use based on what you're like the problem you're dealing with, I would say like if you're dealing with like lists, and like it depends how complicated your lists are. If you're dealing with something like very straightforward, like let's say adding elements of the list, you can just take the single specific template approach. If you're dealing with very complicated data, it makes sense to split it off. And in most cases, if you're doing something like list plus tree or a list plus recursive structure, in that case, I think you should have two different structures, because one is dealing with the list template and one is dealing with your recursive structure or your tree structure. So you should try dividing it into two and dealing with one single element from the list onto whatever structure you're dealing with. Does that make sense to everyone? I'm gonna take that as a yes. In case you're wondering about examples, this is one of the examples you can look at. So essentially you could have extracted single strings from this list and run it. Sorry, not this one. Yeah, okay, sorry, this one, yeah. So we have two specific different complex inputs. One of them is a list, one of them is a specific tree, right? So we can take individual elements out of the list and run it on a different helper function that takes in this full tree. It checks if like how many times the m exists in that entire tree and returns a number to this main function that now returns 1, 1, 1, 2, 0, and so on and so forth. So that's like one of the ways you can like kind of imagine it. Just for the sake of time, I have not kept like a very complicated problem for like multiple complex input. So essentially, let's think of it this way. From the question 2, Captain Holt has a scorecard, but it's difficult to read the data because it only gives you numbers. It does not give you what officer scored how many points. So design a function that, given a list of scores as numbers and a list of officers' name, would combine into a single list of string in the following format. So we want a list of string that has the officer name, space, the semicolon, space, the score in the string format. And we want to figure out who the winner is finally. So for this case, what we can do is we can copy this specific thing. Till here. So I'm going to follow the template, right? If both of the lists are empty, I know I have to return an empty because I'm dealing with list of strings, right? In this case, one of the assumptions we are sort of making is that the list of scores and the list of officer names is going to be similar, because if it's not similar, then we have made an error in terms of like getting the data. So if both of the lists are going to be similar, we are essentially going to never have the case where only one of them is empty. We are either going to have both are empty or both are okay, sorry, this was supposed to be or both are in the cons area, right? So we sort of get rid of this much part. The next thing we want to do is, given both the I'm going to name this L1 and L2. So given L1, which has a list of scores, and given L2, which has a list of officer names, I want to give both the information to some function and return a single string, right? So I could have something like, let's say, change element that takes in these two specific things and gets me a single string, right? And since this single string needs to be added so that we can make a list, we want to use a cons to combine both of these part together. Did I miss something? Yeah. Okay, so we need to work on change element. I'm gonna take a local for change element, but we should have done like a helper instead, just because we're not relying on any global variables. So let's say define change element that takes in a positive integer, and it takes in like an officer name, right? What we want to do is just string append the officer name with like a space, semicolon, space, and the positive integer, right? But since the positive integer is not a string, we need to convert that into a string. So we would do, sorry, not string, we would do number arrow string that would convert a single positive integer into a string and append it to the officer name. I don't have tests for it. Okay, so what we're going to do is I have two examples written that I'll put here, and we're going to run the function to see what the output would be. So let's do get final list that takes in the score list and that takes in the officer list. Once we run this specific thing, ooh, what just happened? Oh, this would be wait, did I mess up something? Score list has 4 elements. Officer,
Line 146. I'm sad to.
sorry, line 146. What did I?
I also think
Oh, it's this thing.
the conditional for the first conditional, shouldn't that be an or empty L1, empty L2?
No, because if I put or, it indicates that one of the lists is empty. In this case, either both can be empty or both can be cons, right? There
Gotcha.
can be,
Misunderstood.
Yeah, so what happens if it's not?
I mean, if it doesn't, if you reach a condition where it's not equal, then you just reach an error condition where it's like all results are false. But in this case, I didn't have the correct recursive call. So yeah, so all of the tests pass, we get a final list, which is officer name, followed by the semicolon, followed by the score. And so based on that, we know Jake won the best detective / genius award. Yeah, so I should have had some tests ready for this, but I missed that. And the only thing I made an error was over here. I called a wrong template instead of the function name and the recursive call. The other thing you could have also done over here, which you don't need to know per se for the exam, but it's good to know, I guess, is, let's say if there was this local, I could have just used a map which takes in the function change element, and it takes in L1 and L2. And so if I block this specific thing, I still get the same output. So map can work on more than one lists. But if you do write a map which works for more than one list, you need to ensure that all of the lists are of the same size, because if you give different size lists, this will fail. And then the second thing is your function now needs to take 2 specific inputs rather than 1. So it's, you don't need to know how map and all of the list abstractions work with multiple complex inputs. It's just something I wanted to point out. Yeah, so don't get worried about learning those concepts. All right, so I'm going to pass it off to Sean and Jonathan to talk about trees and mutual recursion. So I'll stop sharing. And do you have sharing access?
I will try in a second. To start with, I will drop a little start. Oops, that didn't work. I'm trying to drop a starter file into the chat there, but okay, never mind. It's not letting me do that. Okay, we're just gonna work through it, and I'll post the starter file afterwards, and you guys can work through it yourselves. In the meantime, let's see. Gonna start sharing here in a second. Oof. All right, permissions are denied. 1 second. I will be back very briefly.
Okay, Jonathan, do you maybe want to start first, and then we can come back to Sean while he's trying to figure out the permission stuff?
Yeah, I'll see if I can share too.
Uh-huh.
Can you see it?
I guess we can start with trees, and then Sean, like,
Yeah.
when we're ready.
Yeah, so I'm not going to go super deep. We'll let Sean do it first because I think he has a time commitment. And then we'll go back. So you guys can see the Dr. Racket, right? Can you?
We can
There's a chat. There's a chat. Okay. Yeah, so really quick. So trees are a self-referential data structure. And they will contain multiple self-referential fields. So the difference between a tree and a list is that a tree will contain multiple of these. And usually we talk about trees, and we usually mean binary trees, which means there are 2 separate self-referential fields, which are like left and right subtrees. There are trees with like 3 or 4 even more branches, but usually for those types of trees, we'll want just variable size branches, like the very number of branches. So maybe you want like 5 in one tree and like 2 in another sub branch. And for that, we prefer to use mutually recursive data structure. So I'll let Sean explain that. Yeah, and we'll get back to trees later.
Absolutely. Okay. Hopefully the sharing is now allowed. Let me know if you guys can see that. Can you guys see the screen?
Yes.
Okay, perfect. Thank you. Okay, so I was trying to come up with some ways to design some mutually referential data. And so I'm actually pulling this pretty much straight out of Professor Durbinski's lecture videos. One very common thing that I came up with here is basically how HTML is written. So if you guys don't know, HTML is pretty much the language that web browsers are written in. It stands for Hypertext Markup Language. And so HTML uses tags like OL, ordered list, UL for unordered list, and LI for list item to basically describe a web page in order for a browser to interpret and visualize it. So the HTML elements that we will be working with today are the string, image, ordered list, and unordered list. And so right now, I'll share this exam file for you guys later, but I've written a little bit of data for a div, which basically stands for a division or a section of HTML. And basically we use divs to break up web pages into different sections. So here you can see unordered list is a make ordered list of div. Unordered list is a make unordered list of div. So they're effectively the same thing. The only difference between an ordered and an unordered list is that, as you can see in this photograph here, unordered lists just have bullets and ordered lists are numbered. And then a div is going to be one of a string, an image, an ordered list, or an unordered list. So here we have a little bit of an example of each. And let's go start off by designing some data. So let's get to the templates now. Basically, I'm going to start off with designing the template for a div. Temp, div. Oops. And because a div is one of string, image, ordered list, unordered list, I am going to do a conditional statement, so a cond. And there's 4 branches here. And we will have string div to ask whether the div is a string. It will be image div. And we have OL div and UL div. Oops. And so because a string and an image are pretty much built into Racket, we don't need to do anything. We can just do ... div. Basically manipulate the div as it is. Same thing for the image. But for an ordered list and an unordered list, because this is data that we defined, we're going to have to create templates for those as well. So we can call ol-temp, ol, just kind of make a to-do list of things to build here. ul-temp ul. All right, and I believe this covers the template for a div. So yes, because a div is one of string, image, ordered list, or unordered list, we're going to take in the div, and then basically based on what type that div is, we will return something else. And now, because we have to create the ordered list and unordered list temp, we will do that. So define ol-temp ol. And let's see. An ordered list basically just has content, which is a list of div. So then we're going to have to create another template, which is going to be a list of div template. So that will just be ... list of div -temp on the ordered lists content. And I believe that is it for this one. And an unordered list is going to be effectively the same thing. We're only creating separate data for it because it is a separate data type, although its values are very similar. So define unordered list temp ul and call LOD temp on the unordered lists content. And finally, we have one last thing, which is going to be the list of div temp. And that is going to take in a list of div. And for this one, we're going to start off just by writing our own basically list template based template. So it will be empty LOD and cons LOD And this is where it becomes mutually recursive. Basically, a div can have an ordered list or an unordered list of divs. And then in those lists of divs, we're going to have to recurse back to the div temp. So this is the foundation of what mutually referential data is and a mutually recursive function is. It's basically data that refers to another type of data that refers back to the original type of data. So it's going to be like you have a parent function that calls a helper function that then calls the parent function again. And that creates sort of a loop between these two functions that allows you to iterate through relatively complex mutually referential data. So anyways, we already know that we have to call div temp on the first item in the list of div. And that will be it. There we go. And we have to call the list of div temp. So this is just straight recursion, not mutually referential recursion here on the rest of the list of div. And there we go. So now we have 4 templates. We have the template for a div, for an ordered list, template for an unordered list, and template for a list of div. Okay, so now using these 4 templates, I will just include these in the file that I sent to you guys, so you guys don't actually have to come up with the templates. But basically using these 4, we are going to design a function called numDivs that accepts a single div and returns the total number of divs inside of it. So to keep things simple, we're going to just copy and paste our div temp. Actually, we'll start off by writing the signature and purpose statement. So the signature is going to be numDivs, the name of our function, accepts a div. Whoops. And returns the total number of divs. So it's going to be a natural number. And this function is going to count the number of divs inside of a div. So let's write a couple check expects here. We already have some examples up here from the data definition, so we can just use these. So div A is a string, div image is an image, div OL is an ordered list, and div UL is an unordered list. So we call the number of divs on div A, which is just a string. We should expect it to return 1 because div A is the only div that's in div A. And div image is also going to be 1 because basically the image is the only thing that's inside of that div. Now this is where it gets a little more complicated. If we call num divs on div-ol, we can expect the ordered list has basically a list 1, 2, and 3. So we have the ordered list itself, as well as each element in the list, which is going to basically be 3 strings, so 3 divs. It will be a total of 4 divs. Also, I cannot see the questions, so if you guys have anything, just don't be afraid to unmute and ask away. And now we have numDivs on the unordered list. So for the unordered list, we have div A, which is 1, 2, 3, 4 for the image, and then the 4 from div ordered list. So that's going to be 8, I believe. What? 1, 2, 3, 4. Never mind, 9. Sorry about that, because div-ul itself is a div. So now we have all the checks written. And
div template has a little error in it. On line 36 and 37, you call OL template on OL, but OL is not defined. It should be div. And then the same for the next line down as well.
Perfect. Did that fix it there? I believe. Div, ol-temp on the div, ul-temp div. Yes, okay. So now we can copy and paste to this template in. So we know that if the div is a string, the div only has itself as all the divs inside of that div. So we know that that's going to return 1. Same thing for an image. For an ordered list, we're going to have to count the number of divs in the list of divs that that div has. So this is basically telling us that we're going to have to create a helper function here. So I'm going to finish this function off first. So first we're going to add 1 to include the current div. And then we're going to call a helper that's going to be called num divs on the content of the ordered list. And similarly, we're going to do the same thing for an unordered list because they are very similar data types. And let's see, parentheses there. Okay, so now we know that we have to create a helper function, and it's going to be called number of divs in a list of divs. So in this function, the function takes in a list of div and returns a mat because we're counting how many divs are in a list of div. And a brief purpose statement, and start off with checks again. Actually, I'm just going to copy these over because they're going to be relatively similar. Number of divs in a list of div, and we'll make this an empty list. Empty base case, that's going to be 0. Number of divs per LOD, I don't know why that's capitalized. And we're going to take in a list and this should return 3. And finally, we're going to check how many divs are in the content of the unordered list div. And that should be 8. It's going to be the same as the unordered list, just without the unordered list div itself. Okay, and now we can call this template. So we have number of divs per list of div. And what's going to be called on a list. Oh, forgot to copy and paste this one as well. So it's going to be num divs. Okay. So the number of divs in a list of div, we'll start off with a conditional statement again. If the list of divs is empty, does anyone have an idea for what the base case will be?
0.
Yep, 0, perfect. So we're going to return 0 for that one. And otherwise, what is the function we're going to want to call in place of div temp? So we know that we have a list of divs, and the first div in the list of divs is a div. And do we have a function here that basically counts how many divs are in a div?
Num divs.
Do you guys have any idea? Okay, well, basically, because this is a mutually referential data and a mutually recursive function, we know that we're going to have to eventually call back to the parent function. So we're going to actually call num divs on the first div in the list of divs. And then we're going to recurse through the list of divs to find the number of divs in the rest of the list. And I believe that is the entire function. So basically, we have a function here that takes in a div. And based on what type that div is, it's going to either return 1 or it's going to count the number of divs in the list of div for that div. And then this function is going to recurse through a list of divs. And then for each div, it's going to call back to num divs and count how many divs are in a list of divs. So if we run these, whoops, clause with 6 parts, where's it saying this? This is where I messed something up. So forgot that we have to add the number of divs in the first list of div to the recursion. So that's where we create the recursion, and this is a template that is not executing as intended. I'm just going to code that out for now. So excuse me for my sloppiness here. I should have dealt with this earlier. But condition all question results were false. Apologies for this. Am I missing any bugs? Can the TAs help out here? So I'm not wasting too much time debugging my own code. 8.
Wait, can you show me the error again?
Yeah, sure thing. Line 91, caused by line 76. Just forgot to rename the test. There we go. Number of divs in a list of div. Now it should run. Okay, all 7 tests passed. And for the sake of practicing how we can do this using list abstractions, does anyone have any idea how we can simplify the second function here? Or do you guys have an idea for a list abstraction that can do this in a much more concise manner? Yeah, so exactly, you'd want to use Foldr here. So we're going to make a version 2 of this just to make this a little more concise. Define num divs per LOD, and we're going to do v2. And we're going to run a Foldr. And does anyone have any idea what the base case is going to be?
0.
Yep, 0 on the Foldr. And does anyone have any idea what the function is going to be?
Num-div.
Exactly, but we can't just call num divs in the Foldr, right? So I think that Robert has the right idea. So we're going to map the parent function and then run a Foldr on it. It's going to be map over the list of divs. And then after that, we're going to add all the values together. So now we can copy and paste these check expects and rename them, and they should run the exact same way. And all 10 tests passed. So yeah, basically here you have a function that is written over some mutually referential data. It's going to call a helper function, which refers back to the first function. And then we simplified that using Foldr over a map. So does anyone have any questions about sort of, any basics on mutual recursion, or if there's anything you're unclear about? Okay, so why did I use map in the last part? So the reason I used map num divs over the list of div is that if you take a look at this function here, num divs is going to be called over the first item in the list of divs over and over and over as we recur through that list of divs. So by the time we map num divs over the list of div, we are going to turn that list of div into a list of numbers. And that list of numbers is going to be the number of divs in each div in that list of divs. And then we're just using Foldr to add all of those together at the end. So basically, whatever function that you're going to be calling on the first item if you use, traditional list template is going to be what is going to be mapped over the list of divs, because you have to do something over every single item before you add all those values together. Does that kind of make sense? And also for Brett, let's see, how do we know when we need to use mutual recursion? Okay, let's see, how do we know when we need to use mutual recursion? Basically, mutual recursion is going to be used over any sort of mutually referential data. So right now, for example, here, if we look at this example, a div is one of string, image, ordered list, and unordered list. So a div can be an ordered list, which is a list of div, basically. So the main time you want to use mutually recursive functions is sort of when there's nested values somewhere, if that makes sense. Like you can have an item that has a different type of item that has a, more of the original item. It's kind of hard to verbalize here, but something like a web page, for example, where you have like a web page can have a list of links, and then in that list of links, each link is going to be a web page, something like that, where basically you have data referencing another type of data, which references the original type of data. And the reason that mutual recurrence occurs is because, for example, if we just had the div have an ordered list of divs and we just counted how many items were in that list, we wouldn't be going into each div and then calculating the number of divs in that div. So it basically allows for a deeper search of whatever data type that you have. I hope that kind of answered your question. Okay. Anything else? Otherwise, I have another more complicated problem that I will probably simply just post that onto Piazza. It'll be the second problem that Professor Derbinsky has in his lecture videos, but for the sake of time, I'm not going to go over that right now. And that will be actually rendering the HTML code. But yeah, if there's no other questions, I'm going to pass it on to Jonathan in a second. And also, if you guys have any questions after today's meeting, I will be hosting office hours tomorrow on Wednesday as well. So you guys can just drop in and ask away if you have anything. So. All right, and then I'm going to pass it on to Jonathan. Thank you, guys.
All right, hey, can you hear me?
Yep, you got audio.
All right, cool. So I'm going to share. Let's see. Share the whole screen then. Yeah. Okay, so we talked a bit about some of these earlier. So they're self-referential, which means they, a tree will contain as one of the fields another tree, and it'll contain at least two of them. Usually it's two. Sometimes it can be more than two, but I think most of the time you don't need to worry about that. Yeah, sorry.
Could you increase the font size, because I feel it's.
Oh yeah, sorry. How do you do that here?
Yeah.
Oh, this command equals, okay.
You can do command plus. But yeah, that's
okay.
That looks
Is that good?
Mm-hmm.
Is that good? All right. So yeah, so usually they contain two fields, which are like left and right. Sometimes you'll have more than two, but if you ever need like 5 or something, and they're all like different lengths, I think it's better to use mutually recursive data, which Sean just showed. So yeah, so mutual recursion is basically an extension of trees for however many branches that you want. So trees are a union type, so they're one of the same. So they're one of a tree, which is a self-referential data definition, or it can be a leaf. And it has to be a union because otherwise, like you've seen with back when you were defining lists and back when you were defining self-referential data types before you did lists, you noticed that you couldn't just keep self-referencing because you needed to stop somewhere. And here we stop at where we stop at, it's called a leaf. So because of that, we can't we can't have leaves also contain more trees. So leaves have to contain like leaves can be structs, but they can't contain more trees or more leaves because we need it to stop somewhere. So another thing is that tree shouldn't have loops. So if tree A contains tree B as like a subtree, tree B can't contain tree A again. And in Dr. Racket, if you try defining like two constants, that one of which contains the other and the second one contains the first one, you can't do it because you can only use the functions that you've defined first later on. If you want to have this kind of behavior, you have to use a graph data type. And that's not something that's not going to be covered on this exam. So a lot of what we're going to be doing here is basically very similar to what Sean was doing, but we are going to be just doing the very simple binary tree case. So here is the sort of template for that. Yeah, so you'll have a base case, and sometimes they'll matter and sometimes they won't. I think most of the time they won't, but sometimes you might want to do this. And for example, if the leaf is like when we had the files and directories for homework 10, like your directories could contain directories and they'd stop when you get to a file. And you might still want to access that file information, but other times for like ancestor trees, you just had a false here and then you'd stop there. So depending on how you structure your data, you might want to use the leaf or you might not. So here's the basic template. You have a condition and you want to see if it's a leaf or if it's a recursive tree. And if it's a leaf, you stop there and maybe you use the value of the leaf, maybe not. And if it's a tree, then you do something with the data and you do something with some recursive call on the left and the right sides. Here's an aside. So Harsh was talking about I think sequential and parallel processing of lists. There's also a third one that I learned when I took Fundies, and I think you guys might have covered as well, which is cross product. So what cross product does is you have two lists, which is A, B, and C, and you have 1, 2, and 3, and it'll look at all the pairs. So A1, A2, A3, and all the way through all 9 of these combinations. And so how do you do it? So you recurse through the first list and you look at the first element and you pair it. You call a helper to pair it with every single element of the second list. This code I'll also send, both of these I'll send. So maybe sometime later tonight, maybe tomorrow morning. So here's an example we use it for. So students and student grades, if you remember, you had a list of students and a list of grades and you wanted to map each student to a student grade. And in order to do that, you had to, for each student, go through every single one of the grades to see which ones of those matched. So so you basically use this kind of cross product. It was simplified because you were probably using less abstractions as well, but here's the kind of fully expanded form. So that's just something I wanted to make sure you guys were familiar with for the exam. So back to trees. So I showed you this template, and I think we can do an example here. So I'm not sure how much we're going to do, but we're going to try to do the data definition or the data design, and maybe at least one function. So here's Little Alchemy. It's a game that was popular, like, a few years back. So it looks like this, and you basically had these things. You had these elements that you can combine to make other elements, and you would just continue doing that and just like find more and more things. And what I'm using why I'm using this to explain what trees are is because each thing is formed by combining two previous things. So it's really nice for binary data structures. So let me go back to Dr. Racket. And we're going to be trying to do that. So I just showed you how to make a volcano. It is earth plus lava, and lava itself is made from earth and fire, right? So you have 4 of these basic elements, and then you can combine them in different ways to get different things. So, so there are 2 ways to implement these. Actually, you could do a full binary tree, which means that each one of these gets its own, like each one of these is an element. So you say that volcano is an element that is made up of earth and lava, and earth is an element that's made up of nothing and nothing. Or you can use a regular binary trace where the basic elements are leaves. So that's something like volcano and lava are like the only elements, and these guys are not elements, but they're sort of like leaves. So do you guys have any preference to which one you want to which one you want to try out? So again, the options are treating all 6 of these as elements, or treating just volcano and lava as sort of second level elements, and these first level elements will treat as leaves. Yeah, so we can do a regular binary tree, and sorry, I didn't explain what full was. You don't need to know this for the exam, but full just means it has either 0 or 2 children. It just wouldn't make sense for something like Earth, or because each one of these is made up of 2 things, it wouldn't make sense for something to be made up of just one thing. So we can do a regular binary trees where the elements are leaves. So let's think about how we would design these, right? So we need a struct. And so because the basic elements are leaves, I'm going to call this a complex element. And what are the fields of this complex element? So for example, volcano is a complex element. So what will it contain? Any ideas of like what type they would be, or?
Like earth and lava.
Yeah, so what type would those be? I haven't defined it yet, but yeah, this is a complex element. Yeah, so it contained, well, it's not just basic elements, it could be either basic or complex elements. So we'll call it element 1 and element 2. And so you have this complex element that's made up of elements 1 and 2. So you can start with a basic element. So a basic element is one of, how am I doing this? Yeah, so it's one of those 4. And remember, you need an interpretation. So a basic element in the game. And then you need some examples, right? And so we're going to define air as air. Define earth as earth. And so on. And then we have a template. So this is a enumeration. So you just use a cond and you get all 4 of them. So like these, and just going to copy them. Yeah, so this is a basic element. It's just any one of these 4. So this is sort of your very simple enumeration data designs. And this one's going to be more complex because it's a complex element. So a complex element is I'm going to say make complex element because it's a struct. And so for E1 and E2, they could be either basic or complex. So we're going to define a union type. that's called element. That will be on both basic and complex. So right now we have our complex elements, and there are structs. So, okay, so it represents a complex element constructed in the game. And we need some constants. And so I have some of these constants here. So define dust as make complex element, air and earth. You can see that I'm using the constants I've defined before to make these ones as well. So we have dust, lava, and pressure. And we have these second level ones, gunpowder, obsidian, and volcano. And here's earth and fire. Here's earth and earth. So you can combine two of the same things. Here's dust and fire. I'm just doing these alphabetically. The way I've designed these questions, it shouldn't really matter which one is put on the left and which one's put on the right side. So here are the formulas I'm just copying from below. And this is an idea of what the tree is going to look like. So, I mean, if I press run, and I just press, and if I just like showed you what volcano was, yeah, so you'd have like a make complex element, earth, and fire, right? And what we might want is the name of it, right?